Welcome children, welcome to Physics and Chemistry Made Easy. Today our topic is about quantum numbers. So altogether there are four quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Now what do these quantum number tell us about? They tell us about size and energy of an orbit, shape of the orbital, magnetic orientation of the electron in the orbital and spin of the orbitals. These are the four things we come to know from quantum numbers. So if you want to make this topic much more easier for you, then you have to divide this total into five main parts. Like first one is like who proposed this quantum number. Then next is with what alphabet is it designated. Next is what are its values, what are the values it takes. Third one is what does it tell about, what actually it is telling you about. And the fifth one will be what is its maximum value. So there are four quantum numbers as I already told you: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. So one by one let us discuss with these side headings. So the first one is principal quantum number. Principal quantum number. Now, who proposed this principal quantum number? It is Niels Bohr. Yes, Niels Bohr proposed this principal quantum number, and it is designated as N. It is designated as N. Okay, and what are the values N takes? N takes values like N is equal to 1, 2, 3, and so on, which are also designated as K, L, M and so on. Like today we have our own name as well as Aadhaar number. Same way these shells, these are called shells. So this is nucleus, this is a shell, first shell or orbit, second shell or orbit, third shell or orbit, it goes on. So as you know, these shells are represented with N value. N is equal to 1, 2, 3 and so on, which are also designated as K, L, M and so on. So principal quantum number is speaking about this one. Niels Bohr is speaking about what? Shells and orbits. He is saying that these are all designated as 1, 2, 3 and 1, 2, 3 are also designated as K, L, M and so on. Now what does it tell about? It tells us about size and energy. It tells us about size and energy. Now what do you understand by this? So I will give you explanation for all this. Okay, size and energy means what? Suppose say N is equal to 1. Suppose N is equal to 1. Therefore this is the shape of N is equal to 1. Now N is equal to 2. So this is the shape of N is equal to 2. Suppose it is N is equal to 3. Then it will be 1, 2 and 3. Now tell me what is happening. As the N value is increasing, size is increasing. Right? N is equal to 1, N is equal to 2 and N is equal to 3. Imagine N is equal to 4, N is equal to 5. So N is equal to 1. Suppose you can imagine like N is equal to 2, N is equal to 3, N is equal to 4. So what is happening? As the N value is increasing, size is increasing. Right? So it is speaking about size. Now coming to energy, as I already told you in Bohr's model, orbit which is nearer to the nucleus has less energy compared to orbit away from nucleus. So this orbit K, this is our K shell, it has less energy compared to what? L shell. Now because this is K, this is L shell. Now what about this one? K is here, L is here and M is here. Therefore M orbit has more energy compared to L, and L has more energy compared to K. So the least energy one is K. Right? Okay. So it tells about size and energy. And the last and final one is what? Its maximum value is. It does not have any maximum value. This is all about principal quantum number. It is proposed by Niels Bohr, designated as N. These are what I meant to say N. N is equal to 1, N is equal to 2 and N is equal to 3. they are also represented with the designated as n is equal to 1, 2, 3 KLMN, and it tells about size and energy. As the n value increases, size is increasing. As size increases, orbitals increase, and the orbit which is nearer to the nucleus has less energy compared to the orbit away from nucleus. Therefore, it is speaking about size and energy. This is all about principal quantum number. Then comes Azimuthal quantum number. The second quantum number is Azimuthal quantum number. So the Azimuthal quantum number, no, the second quantum number is Azimuthal quantum number. There is other name for Azimuthal quantum number. It is also called as subsidiary quantum number. It is also called as angular momentum quantum number. You should know the other names also, because in exam they can be a question with other names, right? So, and generally we call it as Azimuthal quantum number. Azimuthal quantum number. Right, let us study about this one. This Azimuthal quantum number is proposed by Sommerfeld. Yes, it is proposed by Sommerfeld. Sommerfeld proposed Azimuthal quantum number. Now it is designated as L, small l. It's not capital L, because capital L has got the principal quantum number. And L takes values 0, 1, 2 and so on, which are also designated as S, P, D, F and so on. These are nothing but what? Orbitals. And what does it tell about? It tells us about shape. Why? Because here L, it is L. L takes the values like 0, 1, 2, 3, which are also designated as S, P, D, F and so on. S is spherical in shape, P is dumbbell shape, D is double shape. So it is particularly speaking about shape. Then what is its maximum value? N minus 1. Most of the books we find it as L. Wrong, it is N minus 1. Now coming to this Sommerfeld, name of a scientist, designation is with L. Okay, done. L is equal to 0, 1, 2, 3 as I have told you, S, P, D, F, and it tells about shape, and the maximum value is N minus 1. Now first of all we know what N minus 1 mean. So right, what did I tell you just now? N shells are represented with n value, and n is equal to 1. Now when you speak about n is equal to 1, L is equal to 0. For every orbit, the number of orbitals also remain to be same. So if n is equal to 1, the first value will be 0, and if n is treated as K shell, therefore this S is this 0 is also a number, and it is represented with S. Now n is equal to 2. So what is the value of n? 2. Therefore L values are also 2, 0 and 1. And 0 is represented as S, and 1 is represented as P. Now coming to n is equal to 3. L has got 3 values, 0, 1 and 2. 0 is also a number, like whole numbers, it is also a number. 0 is represented with S, 1 is represented with P, and D is represented with 2. Now what do you understand by this? So n is equal to 1, where L is equal to 0. N is equal to 2 means L values are 2, 0 and 1. N is equal to 3 means L values are 3, 0, 1, 2. Now what do you understand by this? The highest number of L value appears as if it is 1 less than n. What is your n here? 1. So 1 minus 1 is how much? 0. It's like this. For first case, n is equal to 1. That means this one is what? 1 minus 1 is equal to 0. Yes, you got L is equal to 0. The maximum value of L is 0. Now for n is equal to 2. What is the formula here? 2 minus 1. So 2 minus 1 is how much? 1. So maximum value of L is 1 here. 1. Next n is equal to 3. So it is how much? N is how much? 3. 3 minus 1 is equal to 2. So the maximum value is 2. Right. Or else simple way, man. Simple is what? N is equal to 4 means L values are 4. 0, 1, 2 and 3. The last one appears as if it is 1 less than 4. The last value of L appears to be 1 less than n. That means 4 minus 1 is how much? 3. That is its formula, highest formula, right? N minus 1. The third quantum number is magnetic quantum number. Magnetic quantum number. Magnetic quantum number is proposed by Langley. Try to understand, this is a very excellent one, okay? And is this designated as M, or else it will be ML also. It takes values, M takes values minus L, 0, plus L. What actually you understand by this? Suppose, as you know, L is equal to 0, so 0, it is 0. You know L is equal to 1, therefore he is saying that the values should start from minus L, 0 and plus L. That's what it means. If L is equal to 2, he is saying that you start the value from minus, end up with plus. So it's minus 2, minus 1, 0, 1 and 2. Now if it is L is equal to 3, then he is saying that you start with minus value. Minus 3, minus 2, minus 1, 0, 1, 2, 3. So this is what it means. Your value starts with minus L and ends up with plus L. So if L is equal to 1, then your number should start, your value should start from minus 1, as it is told minus L, your L is 1, so minus 1, 0, 1. If L is equal to 2, it is very clearly told that the value starts with the same L value with negative sign, so minus 2, minus 1, 0, 1, 2. If L is equal to 3, then as it is told very clearly, L value is 3, so we start with the negative value, that is minus 3, minus 2, minus 1, 0, 1, 2, 3. This is what you mean by giving the values for the magnetic orientation. This is all called as magnetic orientation. It tells about magnetic orientation. The last one is, its maximum value is 2L plus 1. Now we will see this one, a very interesting one actually. Right. Now what happens, once again I will tell you, because I am going to rub this part. If L is equal to 0, then the magnetic orientation will be 0. If L is equal to 1, then it is very clearly told that you start the value of magnetic orientation with the same L value, 1. So minus 1, 0 and plus 1. Now it is 2, so it is very clearly told your L value should start with the same number. So 2, since it is negative, it starts with minus 2, 0, plus 2. L is equal to 3, minus 3 and minus 2, minus 1, 0, 1, 2 and 3. This is over. We will see this one, 2L plus 1. Before I am going to that one, see, S holds 2 electrons, P holds 6 electrons, D holds 10 electrons, F holds 14 electrons. Where do you see this one? Electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d10. Yeah, it's enough for us up to 30. See, whenever you come across S, notice this one. Yeah, it holds 2 electrons. Therefore, S holds 2 electrons. Wherever you come across P, yeah, this is P and this is P. So P holds 6 electrons. Then coming across D, D holds 10 electrons. Now, there are degenerate orbitals, boxes actually, which are called degenerate orbitals. Each degenerate orbital holds 2 electrons with clockwise and anti-clockwise spin. So each degenerate orbital holds 2 electrons. Now, S has got how many electrons? 2. Therefore, how many degenerate orbitals does it require? Only 1. P holds how many electrons? 6. Therefore, each box holds 2 electrons. Therefore, it requires how many boxes or degenerate orbitals? What we call 3. Now, D holds how many electrons? 10. So, to hold 10 electrons, how many boxes does it require? What do we call these boxes? Degenerate orbitals. How many does it require? 5. Now, you tell me, L is equal to 0 means it is S. L is equal to 1 means it is P. L is equal to 2 means it is D. So d holds how many electrons? 10. How many degenerate orbitals are here? Degenerate boxes are here? 5. So for those 5, you should start the value with -2 as it is told here. Whatever it is, you start the numbering with L value. L is 2. Therefore, it starts with negative value -2, -1, 0, 1 and 2. Now what is this one? L is equal to 1. L is equal to 1 means it is p orbital. Just now previously also I told you L is equal to 0 means it is S, L is equal to 1 means it is P, L is equal to 2 means it is D. Okay, leave it. P holds how many electrons? 6. P means what? 1. L is equal to 1. So he is telling you start the values with negative, end up with positive. What is that? 1. So this is -1, 0 and 1. This is magnetic orientation of the electron. Now L is equal to 0. S holds how many electrons? 2. S holds how many electrons? 2. So for holding 2 electrons, how many boxes does it require? Box we call it as degenerate orbital. It requires only 1. Therefore he is saying L value should start with -L, end up with +L. You don't have that many, so it is 0 in the middle, right? Okay, now coming to the next one. This is understood. This is understood very clearly. We are again speaking about the same thing in a different way. Now we'll come to the formula. The formula is what now? 2L plus 1. So the formula is 2L plus 1. This is the formula to calculate maximum magnetic quantum number value. Now my L is how much? First case 1. Sorry, 0. 0 means what? S orbital. What did I say just now? It requires 1 box. How? L is equal to 0. You place this 0 here. 2 into 0 is 0. Plus 1 is 1. 1. So very clearly it is telling that it requires 1 box. That's it. That's all. Finished. Suppose say your L is equal to what? 1. 1 means what? P orbital. It's easy to remember. S means it is 0. P means it is 1. And D means it is 2. What is that? L values. L is equal to 0, it is S. L is equal to 1 means it is P. L is equal to 2 means it is D. So L is equal to 0, yes. Yes, when you place 0 here, 2 zeros are 0, plus 1 is 1. So you got 1 box, D1 degenerate orbital. That means it is telling you a number of boxes required. Okay, that's what you mean by maximum magnetic quantum number formula. Now L is equal to what? 1. So 2 ones are 2 plus 1 is what? 3. So it is telling that you require 3 boxes. Now let us discuss. P holds how many electrons? 6. To hold 6 electrons, how many boxes are required? 3. Correct. It is correct. So this formula plays a great role. Now coming to L is equal to 2. Which you mean by D. L is equal to 2 means D orbital. Leave it. Now you place this D2 here. 2 2s are 4 plus 1 5. So he is saying that you require 5 boxes over here. 5 2s are 10. Yes, D holds 10 electrons. As you know, S holds 2 electrons, P holds 6 and D holds 10. To hold 10 electrons, it requires 5 boxes. Yes, that is what you mean. See, place this 2 here. 2 2s are 4 plus 1 is 5. So he is telling you require 5 boxes. That is what the formula is. This will tell you how many degenerate orbital. Degenerate orbital, easy to understand, is boxes. Boxes are called degenerate orbitals. So L is equal to 0. If you place 0 here, 2 zeros are 0, plus 1 is 1. So it requires 1 box. L is equal to 1. We will call it as P. Right? We will call it as P. Okay. L is equal to 1. When you place it 1 here, 2 ones are 2 plus 1 is 3. So it is telling that for L is equal to 1 P, it requires 3 boxes. L is equal to 2. You place 2 here, 2 2s are 4 plus 1 is 5. So he is telling that it requires 5 boxes. Now next again, L is equal to 0. So okay, magnetic orientation is 0. L is equal to 1. This is told in the same concept. It is told that the value should start with minus and end up with plus. Same L value, okay, because your L is 1. So I started with minus L and ended with plus L. That is minus 1, 0 and plus 1. Now what is L value 2? It is very clearly told that you start with negative and end up with a positive, same 2. So it is minus 2, minus 1, 0, 1 and 2. This is what you mean by magnetic quantum number. Now the last and final one is spin quantum number. Good. Spin quantum number. Before I am going into the detail, as I was telling you, these are called degenerate orbitals. Degenerate orbitals. You can simply understand like boxes. S has got how many boxes? Only one, because it holds 2 electrons. Okay, I'll write down here. S holds 2 electrons. Therefore, it requires one box. P holds how many electrons? P holds how many electrons? 6. Therefore, how many boxes do I require? 3. D holds how many electrons? 10. So, how many boxes I require? 5. 5. Very good. So, L is equal to 0. So, it's 0. L is equal to 1. This is L is equal to 1. So, starting number minus 1, 0, plus 1. D holds how many electron? 10. What do you mean by D? First of all, L is equal to 0, 1, 2. This is SP and this is D. So, it is D now. D means 2. P means it is 1. That's why I started with minus 1 and ended up with plus 1. Now my D value is 2. So minus 2, minus 1, 0, 1, 2. Each box holds 2 electrons. Each box holds 2 electrons. That means they should not be in the same spin, opposite spin. One is clockwise, other one is anti-clockwise. That is what you mean by spin quantum number. In each box there are 2 electrons. Both electrons are not with the same spin. So that's what spin quantum number is. Alright, and it is proposed by U. Len Beck. So silent, H is silent. U. Len Beck it is, and Gauss-Smith. It is designated as MS. MS. It tells us about, its values are plus half and minus half. Clockwise is plus half, anti-clockwise is minus half. What does it tell about? It tells us about spin of electron. What are those 2 spins? One is clockwise spin, that is represented like this, and the other one is anti-clockwise spin, and it is like this. Last, what is its maximum value? It is again same, plus half for clockwise and minus half for anti-clockwise. This is simple one. Finally, once again I want to tell you what do you mean by spin quantum number. He is saying that each degenerate orbital, whether P is having 3 or D is having 5, it doesn't matter. For each box he is speaking about, it has 2 electrons with the opposite spin. So this is about spin quantum number, and altogether these are 4 quantum numbers: principal quantum number, azimuthal quantum number. Remember, azimuthal quantum number has got other 2 names: subsidiary quantum number, and it is also called as angular momentum quantum number. Among all this, it is magnetic quantum number, which is very important to understand, very easy also. The formula is 2L plus 1. S holds 2 electrons, so it requires 1 box. 1 box means the magnetic orientation value will be 0. P holds how many electrons? 6 electrons, so it requires 3 boxes. What do you mean by P? It is L is equal to 1. So down you will find your value starts with minus 1, ends up with plus 7. But I want to tell you 4 important formulas which come in this structure of atom. The first one is N square. N square, it tells us about number of orbitals. Now we'll see. N is equal to 1, where L is equal to what? 0. L is equal to 0. 0 means it is represented with S. Okay. S has got how many degenerate orbitals? 1. N is equal to 2, where L is equal to 0 and 1. That means S and P. S holds how many electrons? 2, so there it requires 1 box. P holds how many electrons? 6, so it requires how many? 3 boxes. Next, N is equal to 3, where L is equal to 0, 1, 2. 0 means S orbital, it holds 0 is S orbital, so it holds 2 electrons, 1 box, degenerate orbital. 1 means it is P, it holds 3 electrons. Sorry, it holds 6 electrons, so 3 boxes. 2 means what? D. D holds how many electrons? 10 electrons, so it requires 5 boxes. 1, 2, 3, 4 and 5. So here total number of degenerate orbitals 1. Here total number of degenerate orbitals 4. Here the total number of degenerate orbitals are 9. Therefore, number of orbitals is got by the formula n square. 1 square. N is equal to 1. 1 square. The answer is 1. N is equal to what? Now it is 2. 2 square. Your answer is 4. N is equal to what? 3. Therefore, 3 square. It is 9. This is what n square means. The next formula is about number of degenerate orbitals. N square says number of orbitals. Now this says about number of degenerate orbitals. The formula is what? 2l plus 1. Just now we discussed in magnetic quantum number. Now what happens? L is equal to 0. That is s orbital. So place this 0 here. So 2 into 0 is 0 plus 1, it is 1. Therefore it requires 1 degenerate orbital. L is equal to 1, which is called p orbital. So place this 1 here. 2 ones are 2 plus 1 is 3. So it requires 3 degenerate orbitals. L is equal to what? 2. 2 means it is D. Because L is equal to 0, 1, 2. S, P and D. D. Now coming to D, place this 2 here. 2 to the 4 plus 1 is 5. So it is 5. 1, 2, 3, 4 and 5. So 2L plus 1 indicates the number of degenerate orbitals. Now I want to tell you number of electrons. Number of electrons. 2. Already you got number of degenerate orbital formula as 2L plus 1. So if you can multiply this with 2, then you will get number of electrons in degenerate orbitals. Now L is equal to 0, that is S. So 2, you are placing this 0 here. 2 zeros is 0 plus 1 is 1. 1 into 2 is 2. Therefore 2 electrons. 2 electrons. Where are these 2 electrons? In one degenerate orbital, because it is already you got one degenerate orbital. It holds 2 electrons. The next one is what now? L is equal to 1. That is p orbital. So same thing. Take this one, place it here. 2 ones are 2 plus 1 is 3. 3 twos are 6. 6 means 6. Okay, 6. But what about this one? How many degenerate orbital does it contain? 3. So you have to speak in number of electrons here. But the topic is degenerate orbital only. So it is 3. So 3. 1, 2, 3, 4, 5 and 6. The next one is what? L is equal to 2. Which is d orbital. So you take this 2 and place it here. L at the place of L. 2 to the 4 plus 1 is 5. 5 2 side is 10. 10. That means how many boxes does it require? 5. 1, 2, 3, 4 and 5. How? Because D means it is 5. Now this is what? Degenerate orbitals. This is number of degenerate orbitals. Degenerate orbitals. In these degenerate orbitals, to know number of electrons, electron, you can remember it as electron is E. It's E. So you can reverse it like E. It's like this E. E is reversed. Then you will get number of electron formula, and that is here. Number of electron formula. So how many electrons? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That's it. Now coming to the next formula. So number of electrons, what was the formula? Just now we have seen number of degenerate orbitals. Degenerate orbital means boxes. Number of degenerate orbital formula is 2L plus 1. Same way number of electrons in degenerate orbital. What is my formula? Degenerate orbital formula remains as it is. Number of electrons, so it is 2. Now there is one more formula to find number of electrons in the orbits. And the formula is 2n square. Important one. So let us take n is equal to 1. So it is 2 into 1 square. 1 square is 1, 1 into 2 is 2. Therefore 2. Number of electrons in a n shell, n is equal to 1 shell are 2. How? N is equal to 1 where L is equal to 0. 0 means yes, you have only one box. So it holds 2 electrons. Now n is equal to 2. That means 2 square. Because the formula is 2n square. Here n is 2, n is 2. So here n is 2. So 2 square, 4, 4 2s are again 8. Now how? N is equal to 2. L is equal to 0, 1. 0 means yes, P means 1. P means 1, 0 means S. S holds how many electrons? 2. P holds how many electrons? 6. So 2 plus 6 is how much? 8. 8. Okay. Same manner, last and final, n is equal to 3. So 2, 3 square. Because 3, n is equal to 3, here formula is here. 3 is here, 3 square, 9, 9 2, so it is 18. So n is equal to 3, where L is equal to 0, 1 and 2. S, P and D. S holds how many electrons? 2. P holds 6 and D holds 10. On the whole, they are 18. So these are some of the formulas. Thank you.